Hello, everyone. I'm grateful you decided to spend the next 30 minutes with me discussing a super important topic, which, in my opinion, is very popular among engineers and not very popular among managers. While, in my opinion, it should be the other way around, because I'm going to prove today that platform engineering is, in fact, more a topic for managers. So today's agenda will guide you through this idea. I will start on how platform engineering is different than DevOps and what as a service actually really means in platform engineering. We will also discuss how to properly approach the platform initiative as IT management and how to measure if we succeeded with this initiative or not. Then we will end up with SLAs and I think and all the factors which tells us if we have or do not have a platform in our company. Spoiler alert is that you can have all DevSecOps tools around, automated infrastructure as a code portal for developers, and you still may not have a platform. So before we start, I will quickly introduce myself. My name is Krzysztof Hałasa, but you can call me Chris. Last decade, I played multiple roles in IT. I started as a software developer, then architect, and then ended up as platform manager, which I am since 2022, before the platform engineering was that popular and was that cool. So I'm a platform hipster. I've built several internal developer platforms in this role as a manager, and I also advised within IT management and operating model. I like to share my knowledge. That's this meeting we have. So besides the projects, commercial projects last year, I also joined as academic teacher on master studies in Polish-Japanese Academy of Information Technology. And this year, I was honored a Team Topologies Advocate title, and I'm also Polish platform engineering community leader and the meetup organizer. And privately, I am a super big fan of history and military operations. So we will start our platform engineering discussion with one historical example outside of IT. In 1972, there was a conflict between Israeli and Arab forces, widely known as the Yom Kippur War. Israeli and Arab countries were using very similar gear, a mix of Soviet, American, and domestic armored vehicles, artillery units, combat aircraft, basically very similar and comparable gear. Arab forces were 2 times bigger than Israeli forces in this conflict, and yet Israel militarily won this conflict. They simply used the gear they had more efficiently. It was working as a one integrated system, and they used a terrain and their advantage tactic knowledge. Yom Kippur War is also known as one of many examples where doctrine and tactics overcame the gear and material parity, and it's been studied on military universities ever since. And I mentioned Yom Kippur War because I see a lot of similarities on how companies invest in DevSecOps tools and how they organize work of DevOps engineers, not often thinking about efficiency such investment. And organizing those resources around application delivery and operations and platform engineering is actually about this. So 2 years ago, I had the pleasure to work with 2 banks, one in Ukraine, which I will call the Alpha Bank, and one in Poland, which I will call a Beta Bank. Those 2 banks had been in very similar place. They just transformed into a Spotify model, and there was a lot of new teams and new delivery coming to the organization. And each new initiative, or even old initiative, but with the new business requirements, were about to be built in a new way. So by the new domain teams using microservices architecture. And both banks had very similar technology setup. Infrastructure was automated, they were running Kubernetes on premise and so on. And yet the Beta Bank in Poland needed 3 months to onboard the new team compared to 15 minutes in Alpha Bank. And time to market for a new application, new business application delivery from zero, from very the beginning up to the production was 2 times longer in Beta Bank compared to Alpha Bank. All this Alpha Bank achieved using 5 timeless DevOps engineers needed for a company scale. So we just needed 0.02 developer to serve one DevOps, the developer to serve one DevOps, while in Beta Bank we needed one DevOps were serving simply 10 developers. So what appeared to work in military conflicts also works in IT, where operating model defines the efficiency and not the tools we use in the setup. The only difference between those two banks was how they operate their engineers, how they operate their tools. And Alpha Bank was that different because Alpha Bank adopted platform engineering principles. So what is platform engineering? I've selected two definitions. First, more about why, coming from Circus AI, and second is more about how, coming from Gartner. So why do we do platforms? We do platforms to enhance developer productivity by reducing the complexity of the SDLC. And how we do it? By simplifying this SDLC tools and SDLC process for them, offering right capabilities so that developers focus on business value instead of fighting the process or the tools. I like the Gartner definition even more because they named this fighting. They call it cognitive load reduction. And this term goes directly from my favorite definition on key aspects of platform engineering coming from team topologies. So for those who are not familiar with the team topologies concept, we have streamlined teams, platform teams, complicated subsystem teams, and enabling teams in a company. The best way to explain what platform engineering is to focus on those first two. So according to team topologies, streamlined team need to focus only on business value streams. If we talk about business delivery applications, their primary focus is on delivering and operating those application business features. Platform has to simplify everything else. So the streamlined team focus on their job, focus on business value streams. So simplify means provide right capabilities as a service, easy to utilize and easy to understand by streamlined teams without any overheads, without any headache. So we can say that platform team is creating a system to build and operate business applications. Tricky part. Let's establish a common understanding of what as a service in platform engineering means. So as a service means that we have two parties, a service provider and a service consumer, streamline team and platform team in our case. Those two parties has an agreed channel where streamline teams provides input and expect agreed outcomes. And the inputs are easy to gather by streamline team, focused on their true need, so expressing their true need, and understandable by streamline team. So they provide what they know. And the output is an end-to-end comprehensive fulfillment of this need. So nothing more is needed to fulfill the need rather than this comprehensive outcome. So it's also easy to use by the streamlined team. It's fulfilling the need end-to-end. So in other words, any service we use, any service streamlined team use should be as simple for them as ordering a pizza. We just select the pizza type and menu, that's all. We don't inform the cook how to bake the pizza. And remember this definition, because this is the part where so-called platform teams usually fails. And this is also the part where the mentioned Beta Bank from Poland failed. And I'm going to explain now why. So let's start with classic DevOps and how classic DevOps is different than platform engineering. Or is it really different? Okay, so we'll start with the famous "you design it, you build it, you run it." That's the famous sentence in classic DevOps, and that's how basically DevOps started, with this sentence. Platform engineering is also about it, but it's focused on scaling this approach, making it efficient even if we have multiple DevOps teams. Classic DevOps is also about automating software delivery and operations. We do it as well in platform engineering, but Besides, we focus on this automation on reducing cognitive load of stream-aligned teams. So we automate not only to reduce the human error and have some efficiency, repeatability, but also to save developers time and simplify the usage of DevSecOps tools by the developers. And lastly, DevOps is about resilience, it's about scalability and availability, while platform engineering as well, but it focuses on the overall team's efficiency, not just tech capabilities. So in short, we can say that platform engineering is nothing more than a classical DevOps, but in scale. And the tricky part about platform is that you design it, you build it, you run it sentence. So let's jump into it. What does it really mean? Because my experience tells me that it means that different kind of responsibilities if you ask different kind of people. Most of us will agree that teams should build and operate their application logic. Probably none of us will agree that they need to build it from scratch, starting with the building where the servers are located, handling cables in this building, cleaning this building, securing this building, creating microchips, providing servers, etc. But what is in between those two layers can be interpreted differently if you ask engineers. Should an application team handle on deployments and observability tooling, handle on environments and security, or maybe even handle containerization, virtualization, and manage their own infrastructure? Well, this answer can be simple for a small company where managing all of this is not super costly and not super inefficient for each team separately. Small companies, startups, R&Ds. In large companies, we can end up with hundreds of DevSecOps tools and approaches doing the same thing, reinventing the wheel, which is handling those tools which are handling software delivery and operations. It does not sound very scalish, let's say. So let's go back to our two banks. In Beta Bank, the ones which had the longer onboarding process and long and hard time to market, different teams were handling different areas of this cake. And every domain team was composed with both developers and DevOps engineers working in a team. Teams were responsible for SDLC tools, expected to be contacted, like the teams responsible for repositories, for security, environments, containerization, and so on, were expected to be contacted to get access or space within the tools they operate. And each domain needed DevOps engineer to gather all necessary tooling and integrate it into one runtime environment. So in simple words, DevOps engineer was necessary in each team because the team needed to be asked specifically for each capability, needed to actually ask for specific capability separately in order to, in some request form provided by those tech teams, asking details about those capabilities. So how the onboarding process looked like. We had a new domain team coming to the company, eager to deliver new business application. And in order to start doing it, they needed resources. They needed delivery tools, observability tools, and runtime. And here their journey begins. For Kubernetes, they needed to fill some Jira about details in Kubernetes, and they needed to go to the admin team for this. For databases, they need to go to the database team, and once they did, the DevOps engineer needed to then contact a network team to make connections between the runtime and database. Then, for observability tooling, they need to go to the ops team. And again, the network team after this, asking for connectivity of all of those capabilities, and so on, and so on, and so on. And being a manager of this domain team, from this domain team perspective, this journey took up from 1 to 3 months, because all of the tools which was given needed to be then integrated within the pipeline and within the application templates, which was done by the DevOps engineer in domain team. And each domain team coming to a company had a similar path. So in domain team, in order to start delivery, they needed to fulfill this path and also create and maintain tools which were not covered in the company by other teams like QA tooling or specific authorization tooling. And besides that, they were also expected to deliver and operate business features. So if you remember the definition of what as a service means, in this approach, the end-to-end fulfillment of the need, which is onboarding, was missing because they needed to run around. Also, domain team needed to handle technical capabilities by themselves instead of focusing what we pay programmers to do, which are business features functionality. And the situation looked completely different in Alpha Bank, where the platform engineering principles had been adopted. So in Alpha Bank, it was also a domain team entering the company, but they had one Jira ticket, which was called onboarding. What they feel there, they feel programming language they want to use to build an app. They feel application sizing and business criticality. So how many users, and if this is a customer-facing app or not. They put it necessary integrations, like simple names of the system, which APIs the application they are going to build we will use. They delivered who will be delivering the app, so names or email address or of the developers in the team. Platform team had such ticket automated. And in 15 minutes, they provided such a team with Kubernetes cluster, Kubernetes namespace, so a runtime environment, up to production. They provided repository. In this repository, the team found the demo application written in the language and they want to use, integrated with database already, integrated with secret management tool. We've created deployment pipeline, which deploys in all of those environments they needed. So actually they can see how it will operate. With API exposed, with network connectivity to all the systems, like in 15 minutes, domain team were technically able to deploy the first hello world of their application up to the production environment. And after one day, they had all the network connectivity to the integrated systems. So after one day, they were ready to go. And the environment and deployment process they received were already approved by the security. So security testing were focused only on the business application once they want to really release the application. So this is the reason why the time to market for new business application were like 2.5 times better. We saved time and addressed cognitive load on waiting, on going to multiple teams, on configuring what we receive from those teams and learn how to use those things, which was present in Beta Bank in every team. And what is important here that most of the domain teams didn't even require to hire own DevOps engineer. And only R&D, super mature or data teams had this need in such a setup. This is how we have limited the number of DevSecOps engineers just to a dozen, serving almost the whole company working in a platform team. Okay, if you now look at the cake, what we did was establish a clear boundary. You design it, to build it, to run it between the platform and domain team. This boundary had been defined in RASI and in an operating model, and we also defined how platform and domain team works by defining the services. So between the platform and domain, there was a defined services. Onboarding was only one of them. We also had dedicated for new integration. We had one for developer onboarding, for new test environment, penetration tests, etc., etc. Everything we recognized as a cognitive load for the domain teams. What is tricky about platform engineering is that this boundary and definition of services needs to fit the situation in the company. This is why you need to analyze this situation first and then establish the boundary and the services, because what is ideal for one company won't be ideal for the other company. And there can be even several boundaries like this between platform and domain teams, depending on the domain team. So in short, platform engineering done well puts the boundary correctly. So where to put it is an analytical process combined with managers and engineers' work. And it depends on the maturity, it depends on the needs, on the timelines, on the SS situation, sometimes even licenses within the software, the architecture of the software, and so on. Also, platform engineering, once we have this boundary, is also about the services, because we need to design the cooperation between platform and domain team, and define those services which fits the need and maturity of stream-aligned teams. In Alpha Bank, our boundary were within the shared responsibility model between the deployment and observability tooling. But if you run more mature company or R&D or topics related to AI, or even specific software products, what we call as a service can be different. So what is important to understand is that this should be as easy as food order for the domains. This is the service defined properly. Okay, so in order to build a successful platform, you need to categorize the needs. You need to categorize the teams within their maturity. Then you need to design the boundaries in form of operating model and services. And then you need to build and deploy the first version of your application. Ideally, what I recommend is reusing as many DevSecOps tools as you have in your company. So those two first will be the most important and most critical. As you probably already realized, those two, which is categorize the needs and design operating model and services, are not the technology-related tasks. It's a job mostly for managers with some analytical skills and with the support of DevOps engineers. In my experience, it's 80% of overall complexity if we want to introduce platform engineering principles. Mostly because in my experience, tells me that most of the technologies are people are already there in the company. And DevSecOps tools is nothing new in 2024. What platform engineering brings to the table is the way we organize it. So platform engineering is in fact 80% of work organization and only 20% of changes to be applied in technology. And if you remember at the beginning of my speech, I said that platform is a system which supports the delivery and operations of other systems, the business applications. So the right approach to deliver the platform is an usual approach we take delivering the systems. Platform, just like any other system, requires 3 steps: analysis, delivery, and operations. There is work to be done in each step, both from organizational and technical perspective. In analysis phase, we do this cognitive load recognition, and based on this, we create an operating model and services. In my experience, this is often followed by the team's organization changes as well. So platform is a wider topic just than organizing the DevOps teams. Engineers also should do their analysis based on the platform engineers, based on the current technology stack and definition of services. There is a platform to be designed and permission model in DevSecOps tools to be planned. Then we go to the delivery phase, where all of this plan in analysis phase needs to be implemented and deployed. We do the organizational changes, we implement ticket structure or portal, we implement orchestration in DevSecOps layer, and we implement and advertise in a company internally our communication channels. And then when we have operations phase, where our platform is live, here we need to monitor if it's going to the right direction and make sure that needs of the stream-aligned teams are addressed and that stream-aligned teams are migrating to the platform without any headaches. This is an approach to platforms, which I concluded into one of the first management framework in the world, I hope, around this topic. And I created a course for IT managers so they can successfully deliver their platform. Till tomorrow, the course will have 20% discount on this IT manager code, which is valid for 24 hours up from now. The whole analysis, delivery, and operation phases are detailed there, together with the list of my failures and lessons learned I had. You will find the analytical methods to define platform and platform operating model and services. You will find their insights on how to build business case around the platform and how to address this topic in the company on the proper level. All together with some ready-to-use templates for the platform service layer and operating model design. Okay, so I said 80% of the work is organizational and 20% is technical. So let's very quickly look at those 20%, because without technology, platform will be just as a bottleneck as it is, not a solution for a cognitive load addressing. I recognize 3 architecture layers within internal developer platforms. First is a DevSecOps layer, which usually is present in most of the enterprises, sometimes 2 present. Platform supports the cleaning up and automation in this level, so we don't have duplicating capabilities or redundant instances. What platform introduces are two layers on the top. Service layer, where there are orchestration scripts and to implement the platform services we defined. For example, if we have onboarding, there will be scripts creating namespace, indexes, and observability, creating a repository, placing a deployment, adding application to Argo CD, etc., etc. And in DevOps interface, which is a serving layer, is implemented the communication method. So stream-aligned teams can request the services. It can be Jira, it can be APIs, it can be a dedicated internal developer portal. While ideal situation is where the interface triggers the right scripts in a service layer. So we achieve some kind of self-service where the developer need is fulfilled without the presence of the platform team member. So even less bottleneck. If platform sounds as complicated initiative, you can think now, okay, do I really need all of this? Is it worth the effort? So let's make a quick calculation. Imagine you have 10 application teams in the organization. Each team has 6 developers. Average salary of one developer, $50 an hour. Seniors will earn more, juniors will earn less. Let's say that each team in this setup creates one application release per month. And this release, without platform services, takes 1 week of some technical and organizational work of the team. At the beginning, when the team is onboarded, it can be a month. And then when they have pipelines, when they have everything, it can be concluded in a few days. So overall, 1 week. Platform usually takes care of all of this 1 week. So reduces this 1 week. And if we reduce just this 1 week to few hours, we can save over $1.5 million yearly in a small company. It's like 20-30% of the overall SDLC cost. So I think the game is worth to play. Okay, we are closing to the end, so let's discuss how we organized that the platform was a success or not. As a military history fan, I've divided the metrics and success measures into 2 categories: tactical one and strategic one. Tactical, which are directly around the platform, like service fulfillment time, availability, time to fix, the back of the platform, the cost of the service fulfillment, etc. And strategic ones, which are more about the impact the platform have on the whole SDLC, on the whole company, like time to market. But time to market not for the platform, but for the business applications. So how many applications are migrated, how many DevSecOps tools we had outside of the platform, how many technical tasks are in the developers' backlogs. Of course, not everything depends on the platform here, but platform should positively impact those metrics. I personally like to combine metrics from those 2 categories together so I can always see the big picture. Okay, one last question to be asked today, and we can jump to quick Q&A. And the question is, do I have a platform in my organization? Or if there is a platform team, how to check if they deliver what is needed? There are some indicators that something is wrong besides those measures. So there are often few of them, which are easier if you have a feeling that probably you're right. Okay, first one is poor time to market for the applications delivery, or high cost of the applications delivery. Second, a lot of people involved in critical bug fix. Means that boundaries were not set up properly. A lot of permission granting requests. It indicates that the need is not fulfilled, that the team is not served by the comprehensive outcomes, but served with some kind of tools. Long onboarding time, obviously. A lot of those DevSecOps tools. If you have a feeling you have too much, probably the platform is missing. A lot of tech-related tasks in the stream-aligned teams, delivery teams, backlogs. If team is spending time on configuring something instead of delivering business features, platform may be missing. If you need to hire DevOps engineer in each and every team, it's also an indicator that maybe some things can be standardized and some things can be outsourced to the platform. Okay, thank you for your attention, and it's time for a quick Q&A right now.